Alright, ladies and gentlemen, this is the first couple of lessons of Unit 1. We're going to be talking about estimating large numbers. Okay? So here, the first concept we're going to look at is, let's say we have a crowd. Or we have a place where a crowd can gather. We need to estimate that crowd size. So estimating the number of people in a large crowd, for example watching a parade or attending a political rally, is quite challenging and often leads to controversies. One method sometimes used is to focus on a small section of the crowd, such as a rectangular area. And one rule of thumb for estimating crowds is that each person occupies 2.5 square feet. Use this rule to estimate the size of the crowd that could be watching a parade along the 1 mile section of the route in question too. So we're going to use the rectangular area concept on a small scale and then look at that 1 mile section of a parade route. So suppose you're at a venue for a small concert. The dimensions of the venue are rectangular and it is 25 feet wide by 42 feet long. What is the approximate crowd size that could attend the concert? Well, we're going to use the 2.5 square feet per person identified above. So we'll draw a rectangle 25 feet wide and 42 feet long. Find the area of that rectangle. We multiply 25 by 42 and we'll get 1,050 feet squared, or square feet. Then we take the area divided by how much area each person occupies. So that's 1,050 divided by 2.5, and we get 420 people. Now that's an estimation for how many people could watch this concert. And one application of this is, how many tickets should we sell at this venue based on how big the venue is? Well, the people who own the venue should only be selling 420 tickets before the concert is sold out. Now we want to use this value to estimate the size of a crowd that's 10 feet deep on both sides of a street standing along 1 mile section of a parade route. So I got a little crazy with the drawing, and let's just say the 1 mile section of street curves. It's basically the same principle as if the street was rectangular. There might be some slightly more advanced techniques that we could use, but we're just trying to get an estimate. So really it doesn't matter if the street is straight or if it's curved, if all we're doing is finding an estimate. So our 1 mile is 5,280 feet, and the sidewalk to watch the parade is 10 feet deep on both sides. So what we have to do is multiply to find the rectangular area. 10 times 5,280 is 52,800. And we're going to multiply that by 2 because there's two sides of the street. That's what the word both means. It means 2. Multiply that by 2, we get 105,600 square feet. That's the area that people could be standing to watch this parade. So we'll take that number, 105,600, divide it by the number of square feet per person, and we will get 42,240 people approximately could be watching this parade. Another method we could use to estimate a crowd is looking at a picture like this. And then we could divide this picture into sections that are approximately equal because it's an approximation technique. And we could count the number of faces we see in one square. And then maybe we could see 55 people in one of those squares. And we could make the assumption that there is an average of 55 people per square. Well, there's 12 squares, and 12 times 55 is 660 people. And again, that's just an approximation. You might be able to count each face in this picture and come up with a number higher than 660 or less, but it is an estimation. And based on the number of faces in this picture, 660 might be pretty close. And guys, that's estimating large numbers, especially crowd size. Stay tuned for the next installment of Estimating Large Numbers. We'll talk about the counting principle.